Okay, this is still test review number 3, which is covering adding and subtracting fractions and least common multiple using prime factorization. So I'm on problems 26 and 27, and I'm going to show you a couple of ways to do least common multiple. One of them is a shortcut, although I still think prime factorization is a better way to go. Alright, so on number 26, with these 4 numbers, finding the least common multiple means if you list as many multiples of 7 as you can, and list as many of 14, 21, and 36, if you've got a list of all of them, and I did this in problem 24, then you can look at the lists and decide which is the common multiple between all 4 numbers, and then what's the lowest one. Well, there's a way to also make a list and not have to make a list of each of these numbers, but only making a list of the biggest number. So that's what I did over here. I made a list of multiples for just the number 36 up to 10. And what we do, instead of, like I said, instead of listing it for the rest of them, you take each number, so for example 36, the first one, and you see if 7, 14, and 21 divide into it. Now, on the test, this is hard because you're going to just be using your paper. If you have a calculator, of course, it's much easier. And I can tell you that, of course, none of the numbers 7, 14, or 21 will go into 36. So you go to the next number, 72. Will that one divide into 7, 14, and 21? Well, really, the sticky number is 21. When you have to find a multiple that goes into 21, that's going to be really the one to find. So the first one of these numbers that goes into 21, I don't think it's 72. No, it's not. I have a calculator. I'm cheating. But you could divide. And I could do that, but I'm just trying to save time. So 108, I'm going to look to see if 108 is divisible by 21. It's not. Then I'm going to go to 144. And the reason I've picked just 21 is because if I find one that's divisible by 21, then I can check the other 2. But I'm just saving time. I don't want to check them all 3 at once. So 180 divided by 21. No. So far none of these numbers divide by 21. Now we have 216. No. 252. 252 divides by 21 12 times. So we know that works for 21. So let's put 21 next to it. And of course it works for 36. And look at this, 36 times 7. So 252 is a multiple of 36 and 7. And look at this, we got 7, 21, 36. All we have to do is see if 14 goes into it, and we will have found the least common multiple. So we know that all these numbers go in. 14 times 18 is 252. So 36 times 7 is 252. 21 times, I forgot, divided by, 21 times 12 is 252. And 14 times 18 is 252. So that's our least common multiple. So that's another way that saves you from listing all of them. You list the largest one, and then you divide each multiple to see if it's divisible by the other numbers. Well, that's long, in my opinion, too. And I did it quicker because I was using a calculator. So it really does, I think, pay to learn how to do the prime factorization, although to some of you that might just seem too overwhelming. But here's the good news. If you can do prime factorization, at least that, you get partial credit for showing me the prime factorization of each of these numbers. Okay, so finding the prime factorization of each of these numbers doesn't have to be a difficult task. And I explained this in another video, or the one I did for 24 and 25. that you don't have to do cake methods and tree methods all the time. For 7, the prime factorization of 7 is 7. Because 7 times 1 is 7. But 1 is not a prime number, so it is simply 7. That's that. So now you can find, or let's do the prime factorization of 14, which is just 2 times 7, because both 2 and 7 are prime numbers. So that's done. Now the prime factorization of 21, that's not going to be hard either. What do you think of when you think of 21? Well, I think of this, 3 times 7. Both those are prime numbers. So you have the prime factorization of 21. Not bad so far. 36, okay, a little trickier, but really not that much of a problem. I don't know what comes to mind, whether you think of 3 times 12 or 6 times 6. Either one works, or even 9 times 4. Let's use 9 times 4. 9 times 4 is 36. Well, 9 is not a prime number, neither is 4, so we have to keep breaking them down. 9 will break into 3 times 3. Okay, those are prime numbers. Good. We're done. Now 4 breaks into 2 times 2. Those are also prime numbers. So we've got it. 9 times 4. That's our prime factorization, but we're going to write it in canonical notation, or an abbreviated canonical notation. I'm not going to explain that all the way. What I'm going to do with that is just understand that I'm turning 3 times 3 into the exponent 3 to the 2, 2 times 2 into the exponent of 2 squared. So that would be the notation you want to use. Alright, so now you take, and I explained this in problems 24 and 25, you look at all the big numbers, or the base. These are bases. Even though there's no exponent on this number, that's still considered the base. If you put the exponent of 1, it's still 7. So, 7, 7, 7, we only pick one. We pick one representative of each base. So we have to use the base 7. We have to use the base 2. And it doesn't matter, 2 does not have to be in all of these examples, only one of them. But we do have 2 in 2 of them, so we have to choose. Do we use 2 or 2 squared? Well, you choose the one with the higher exponent when you're dealing with least common multiple. You will learn in 060 about greatest common factor. However, right now, least common multiple, choose the highest exponent, 2 squared. Now you have the only base left is 3, but you've got 2 to choose from. This 3 or the 3 squared. Choose the highest exponent once again. So then that's 3 squared. Now you pulled all of those out because when you multiply these, you will end up with the least common multiple of 252. And let's see if it works. 2 times 2 is 4, 3 times 3 is 9. 4 times 9 is 36. So what we're looking at is 7 times 36. And that's because this exponent is 4, this one is 9, 4 times 9 is 36. So what is 7 times 36? I'll go ahead and work it out like you would have to on a test. 42 period 4, 21 plus 4 is 25, and voila, you've got your prime, your least common multiple of these 4 numbers using prime factorization. And this is another way to do it up here by listing the multiples of the largest number and then finding which of those multiples divide into the other 3 numbers, which is what we did there. Okay, now I'm just going to look at the prime factorizations of these numbers. I am not listing the multiples of 150. I started to do it, and you have to go really high before you're finding the common multiple. Alright, so 45. These are larger numbers, but still, they break apart pretty easily. Oops. the prime factorization of 45 is 9 times 5. Well, we're not done yet. 9 times 5 is 45. 5 is a prime number, so we'll keep that one. 3 times 3 is 9, so we break that apart. Now we have prime factorization, and then we're going to put it in the exponent form, 3 squared times 5. And that's our prime factorization of 45, and I'll circle that. And now we have prime factorization of 28. So that would be 28 equals, I just pick any multiples that I know will work, or factors that I know will work. 7 times 4. 7 is prime, so I keep it. I have to break 4 down because it's not prime. Remember that even numbers are not prime. So the breakdown is 7 times 2 times 2, so I rewrite it in an exponent format. And there's the prime factorization of 28. So let's move to number 150. And you think, oh gosh, it's so high. Don't worry. 15 times 10, right? Anytime a number ends in 0, you know that that it can be multiplied by 10 or divided by 10. So 15 times 10 is 150. Both of those numbers are not prime, so we keep breaking them down. 15 breaks down to 3 times 5. 10 breaks down to 2 times 5. So now you have 3 times 2 times 5 squared. So I'm going to move this 3 and 2 next to each other and put the 5's into 5 squared. So that's the prime factorization of 150. Now you look at all these choices. You've got 3 as a base, 5, 7, and 2. Once again, they doesn't matter. The 3 is not here, but that's okay. 5 is not with these guys, that's okay. You take the representative, in other words, there's one base number that you're going to use. So we've got 3, and we've got a 3 here, but we take the base with the higher exponent, so we do 3 squared. Okay, we're done with the number 3. Now we look, let's find all our 5s. So we got a 5 there and a 5 there. We take the base with the higher exponent, so 5 squared. We leave this other one alone. We have a 7, just one, no exponents, so we just pull that one. 2, we have 2 to choose from also. We can take 2 or 2 squared. Take the one with the higher exponent, 2 squared. Now when we work out the math for these exponents, we will have our least common multiple between these numbers. So I'm going to work this one out a little more carefully. 3 squared is 9. 5 squared is 25. I'm just bringing the 7 down. 2 squared is 4. Okay, so now we got rid of all of our exponents. I'm just going to split it into, let's see, 25 times 4 is 100. So I'm going to write that down, and then I'm going to do 7 times 9, which is 63. See, anytime you can find ways to make life easier, do it. Multiplication is commutative. You can multiply these numbers in any order you like. So I multiplied 4 times 25, which is 4 quarters, 100 or $1. Okay, and 9 times 7 is 63. Now I have a shortcut. All I have to do is put 2 zeros on the end of 63, and I'm done with my math. I have the least common multiple, LCM, of, follow my arrow, here it goes, those numbers there. Least common multiple, 6,300. And this one, the least common multiple, let's be rude and just travel it all the way around. Think of those 4 numbers there is 252. Okay.